Okay, yesterday we already done. Okay, at least first part of the transistor amplifier. And make sure you understand for the capacitor, they will be shorted for the AC and they will be open for the DC. That are very, very important. That means when capacitor, they get full charge. So no current can be, okay, go through that. Okay, now again, if you want to go in more detail for the AC amplifier analysis, then this is a step you must be get through it. First thing you have to be complete for any DC bias. Okay. Second thing, on of the capacitor, they will be shorted. Okay. AC coupling or bypass capacitor. Then visual on the DC supply voltage at the AC ground. That means you didn't see any DC power supply in AC module. Replace the transistor by its pi or T module and draw the AC equivalent circuit. Okay, now this is the transistor itself for the AC module. This is the collector here. And this is the collect ammeter. And that will be the base. Okay, the current IB going here, current IC going down, and IE will be leaving. However, the difference will be, you didn't see the DC symbol for the transistor. That's a DC symbol. And that will be a AC. And you can see between the base ammeter, you get a diode here. However, in the AC module, they don't have any more diode. They substitute by the resistor. And that's what they call R prime E. And R prime E will be doing calculation by this formula. 25 millivolt divided to IE. Okay. This is basically for amplifier. You get the gain, you get the input, you get the output. Gain equal output divided to the input. That will be a basic for the amplifier. The first thing we'll be learning, that's what we call a CE amplifier. CE means called common ammeter amplifier. So when you see the common ammeter, that's only telling you in the AC circuitry, ammeter will be grounded. That's what they call a common ammeter. Common base in the AC module, base will be ground. And common collector, they're telling you in the AC module, collector will be grounded. Okay. First thing we're talking about common ammeter. when you're looking into the circuitry, you're able to recognize that is a common admitter. In order to know, looking with the relation between the input-output for the common admitter, input apply to the base and output from the collector. Then you recognize that will be a common admitter. And also you understand the input signal and the output signal. They will be 180 degrees our phase. Okay. C1 and C2 is the DC blocking or AC coupling. That means they only allow AC go through capacitor, okay, not the DC. That's what the name for DC blocking, AC coupling. And also you get the C3. C3 will be get the name a bypass capacitor. Bypass capacitor. That means at the admitter here, if you measure AC signal, you're supposed to get a 0. The thing a capacitor will be shorted to the ground. So current AC will be go through the capacitor, go to the ground. They not go through RE. So that's why they bypass. What they bypass? They bypass the RE. Okay, so with the bypass capacitor, then the gain of the amplifier will be increased. Okay, without the bypass, the gain will be reduced. That is the purpose for the bypass capacitor. This is really for your technician. When you're looking into the CE amplifier, then they try to identify what signal, okay, will be at a certain point. First thing, you get a sine wave here. You see the 0 here. They're supposed to be no DC. So when they go to the capacitor, this signal will be go to the base. However, at the base, you get 2 voltage. Okay, one will be 1.8 DC voltage when you're doing calculation DC. Okay, and this sine wave will be a very, very small. For example, here, 100 microvolt compared to 1.8 volt DC. So if you want to measure the signal AC at this point, your oscilloscope must be set to AC coupling. So they will be removed 1.8 volt. That's why you can measure that sine wave. Otherwise, if you set to DC coupling, you cannot measure that. They very, very small signal. Okay. And at this point here, admitter, you measure, you can get 0 volt for AC signal. The thing is they bypass, they go to the ground. At the collector here, you can get 2 voltage. One VC equals 6.04 volt DC, and another one will be the sine wave. And if you compare the sine wave here and the input here, one going up, the other going down, okay? That means they opposite. Or we can say they will be 180 degrees our phase. So this capacitor, they not allow 6.04 go to the output. They get only sine wave go to the output. The thing is C2 will be blocked DC. So you can see right here in the middle, 6.04. However, after the capacitor, now they could be a 0. No more DC voltage. Okay, try to make it clear for everyone. The thing is you have to do on the lab. And also at work, you still have to working on this kind of the circuitry. Try to understand at a certain point what the voltage DC or AC supposed to be, and how to using your oscilloscope to measure the AC signal.
Mr. Chairman, may I ask one question?
Yeah, go ahead.
Can you repeat the part, because I missed that, the part about the gain and the emitter, where you have the capacitor shortened to ground, and you said something about the gain?
Yeah, that means if you get the bypass capacitor here,
Right.
the gain will be increased. More gain. Without the bypass, the gain will be reduced.
Okay, thank you.
You're welcome. Okay, that common emitter. And now, what they want to do. Let's see. Okay, they want to do your calculation. Now, who done for this calculation? We want to get through it. Try to record it for the other student. If they not get through it, they get the time to review, to working on. For technician, this is basically you have to get through it anyway. So what the VB you think you get? Who get that? Remember, you want to be a technician, you have to do your homework, review, go over the handout. Okay? Nothing for free. You only get free the thing that you don't have to pay anything. Only thing you have to working, okay, in order to be a technician. You get paid, want to get paid more, you want to get more skill job, then you have to spend time to working on. Okay, who get that answer? Just let me know.
2.9.
2.9?
2.83.
You say 2.83. Okay, if you get a different answer, just let me know.
No, 2.83. Okay.
Yeah, 2.83 volt. And VA will be 2.83 minus 0.7, 2.13.
Yep.
And the current IE will be equal VE divided 560. Okay, let's see, 2.13 divide 0.56.
3.81
0.8.
3.81 millivolts.
Yeah, 3.8. That's okay.
Sorry, milliamps.
Milliamp. IB 3.8 divide 151. Okay, you get 0.025 millivolt.
25
Yeah,
25 microamps.
right. 0.025 milliamp. If you can want to get a microamp times 1,000. Okay, I see. That means 0.025 times 150. 3.75. Okay, VCC means 12 minus IC 3.75 time RC 1K. Okay, what you get? 12 minus 3.75. 8.25. VCE. VC minus VE. Okay, VC 8.25 minus VE 2.13. Okay, 8.25 minus 2.13. 6.12. Okay, finally, R prime E 25 divide IE 3.8.
$6.56.
6.56. Oh, okay. Any question about that calculation? Okay, if it's not, we go next one. Okay, the one we already calculate AC.
And Mr. Pham, did you cover the beta yet? The difference between an AC beta and a DC beta?
Now we're talking about DC calculation here.
Okay, all right.
And now we go to AC. AC calculation.
Right.
First thing R prime E, we just doing calculation. 6.580. Okay. And now you want to calculate the R in base. What is the R in base? Telling me what is R in base?
The input resistance, right? Of the amplifier. You got an output resistance and an input resistance.
Yeah, it's the
that is
resistance from the base to the ground.
exactly. You have to go more detail.
Okay,
Okay. R in base, that means resistance from the base to the ground. If you're looking into here, okay, the resistance from the base right here to the ground here. That's what they're looking for.
okay.
Okay. The thing is, you can see the difference. Now, R in base, that means the base to the ground by Ohm's law. That's what I try to go into the detail for you. Equal what formula? R in base. You already know resistor from the base to the ground. So I want to know to calculate the resistor from the base to the ground. Basically equal what formula?
Well, it's going to be the voltage in through the base divided by the current.
A little,
current cross.
a little different. They will be equal. Normally Ohm's law, you want R, you get V divided to I. However, that's a general formula for the Ohm's law. When you apply the Ohm's law, then you must be know V, what V? I is what I.
VB over IB.
What V?
It should be the voltage into the base.
VB, right?
Correct.
Okay, correct. VB. Divide. What current?
IB.
I-
IB. That's a basic definition. Resistance from base to the ground. They will be equal VB divided IB. Okay. And now let's see. AC module. Where? Okay. This is, you see that? IB. Okay. VB. Okay. That means right here VB equal IB to the ground. Okay. So what VB equal? VB right here. What VB equal? VB to the ground here.
IE
IA, correct. Right here.
time RE.
R prime E, right? IA. Time R prime E. So now we're going back here. Okay. They will be IA. time R prime E divide.
Is that a little IE or big IE? Big IE is DC, right?
Yeah, this is AC.
Yeah, so the IE should be little IE?
Now, a little e.
Okay,
You know, they can using both, doesn't matter. But
okay,
using E lower K, B lower K, that telling you they will be AC.
okay.
Okay, now what IE equal? IE equal 1
1 plus beta. Oh, yeah.
plus beta times
E
I
IB.
IB. Okay, so IE now will be equal. Instead of using IE, I using 1 plus beta IB time R prime E. Everything divide IB. So IB cancel out. Finally, R in base equal 1 plus beta time R prime E. Okay, that is how they given right here. They ignore 1 plus beta. They just using the beta time R prime E. However, they using beta AC. In the case, they given you beta AC. If they not, then you can just the beta. Okay, doesn't matter. That is just to prove the formula for the R in base. Okay, but the thing is, you want to do calculation, you just apply this formula. This just try to give you how come we can get that formula. Okay. So what you need to do, you're doing calculation for me, R in base. Telling me what you get.
Hey, Mr. Pham, on the beta, you got the DC beta and you got the AC beta. So are you saying use either one?
No, normally they given you only one. However, sometimes they given you AC and DC. Now going back to this circuitry here, I believe they given you. Let's see where the circuit. I try to see we on right here. You see right here.
Okay. So the difference is only like 10.
Right, not much thing. So that's why if they not given you beta AC, then you just using the beta DC. So now we're using beta 160. Okay, beta AC 160. Okay, so do calculation for me. R prime E, we already get 6.58. Do calculation R in base for me. I in B will be equal beta AC time R prime E. Okay, let's see. Beta AC 160 time 6.58 1052.8.
Yep, correct.
Or 1.1 KO either way. Okay, in total. Okay, so basically, next time we have to add in one more slide to draw for the in total, in base. Now I can draw this for you. You can see. This is the generator. And first thing you get one R1. Next thing, you get another one. R1, R2, and you get another one. B that are in base, okay? And that will be the base. So if you're looking from the generator into the amplifier, that's what they call in total. Okay, so I in total equal okay, R1 parallel R2 parallel R in base. Okay, so R in total equal 1 divide 1 R1 1 R2 1 RB. Okay, and they will be equal 1. Let's see, R1 22K 6.8K. Okay, 22K. 1/6.8K. 1/1.1K. Okay. So now you just doing that calculation for me. I want to know
907.7.
908.
you said 908.
Correct.
907.767.
90, right?
Yep.
Yes, 908.
What else? 908K.
It's approximate 907.8.
That's okay.
It's just 908. It's smaller than the smallest resistor.
KO. You can see you never have to do that type of calculation, but I would like you guys to know, okay? So you really understand in the AC module.
Yeah. Mr. Pham, is that 0.908 kilo ohm?
Yes, ohm.
Is
Just
it-
908. It shouldn't be 908K because it's smaller than the smallest resistor. The smallest resistor is only 1100K or
So
1100.
it's 908 ohms, not kilo.
Okay, iOS ohm.
Yeah, it's
Thank you.
ohm.
The thing I want you guys to do calculation. Okay, iOS ohm. And now they say output resistance. That is really missing the pay on that. Let's see, pay 34, 32, 34. Adding pay. Okay, I try to draw that one for you for AC module. Why? Okay, R1, R2, RB. This is the base here. So basically, you can get okay. This is the base. Okay, this is the collector. And now in the collector, one resistor, second resistor. Okay, let's see what resistor here. They will be 1K RC. Where is the load? Here. 1K and 5K. That will be a 1K. And that will be 5K. And that will be V out. Okay. So if you're going down here, R prime E. Okay. This is the add meter. So output resistance, you're looking from collector here. They can say either G out, okay, or they can say AC out. Now, RC, output resistance, G out. So, G out will be equal. Easy for you to see. Equal what?
Parallel
1K parallel
1.5K.
5K. Okay. And now you can calculate.
900,
Yeah.
956.5.
So 5 divided to 6, right?
Yep.
You get
I get 833.
0.83 K.
Yeah, 833 ohms.
Yeah. Or what? You multiply by 1,000, right? If you want ohm. So 833. Okay. Finally, AC voltage gain. Okay, that means A, the gain, okay, normally equal this is the V in right here. This is the VB. So by definition, for the transistor amplifier, so the gain equal, and you already know, the gain equal out divided to the in, V out divided V in. However, when you apply to the circuitry, then you have to identify what V out and what V in. So now can you tell me the gain of the transistor equal A equal what? The ratio between V out divide look at telling me what
VN.
V out divide
Yeah.
what
Yeah.
Gain is V out over VN.
now.
Yeah.
Why I
Oh, I see.
Yeah,
Oh,
with
I,
an LVN.
no, I know what he's saying. It's something different than that.
yeah, why I'm so saying not. You cannot say V out here, divide V in here. No, that is not why. I can tell you why.
It starts where R1 is at. That's where it really starts.
I can tell you why. Okay, now that's a generator. And a generator, they can get what in here?
Internal resistance.
Interested.
That's what we call F.
Source resistance, internal resistance.
You see that?
Right.
So you cannot say the gain of the transistor here, V out divide V in is not right. They must be V out divide to V.
VB.
Exactly. V out divide to VB.
But that would still be the same as where R1 or R2 is at as well.
Right, same thing. Up to this point.
Right, exactly.
But
That's what I meant when I said R1.
not V in. Okay?
Right.
Okay. V out divide to VB. Okay. And let's see. Is it they given you AV right here? R, C, or G out. Same thing. Divide R prime E. So equal G out divide R prime E. That's what they given you, the formula. Okay, so the gain G out, we already calculate G out, 833 ohm, right? R prime E, we already done 6.58. Let's see, divide 6.58. The gain equal 126.6. Okay. That means the gain for the transistor 126.6. So if you want to design amplify with the transistor, you want more gain, then you better using CE amplifier. The thing is, the next one, CC or CB, the gain not much. That is for the gain. And if they say they want V out, okay, V out. In this case, they will be use A, the gain, time V in. 126.6 time V in. Let's see what V in they given to you. 10 millivolt IMF. 10 millivolt IMF. So output will be 1, 2, 6, 6 millivolt IMF or 1.3 volt. Okay, that only happen if you don't have a this resistor. Okay, if you get the RS resistance, that's a different story. But for this problem here, up until this point, there's a complete calculation for the AC module. Okay, I will be adding more detail on this AC calculation. That means I will draw that thing here, okay, to give you guys more detail. The next time, update it. The thing that really need for any technician want to learn more. Try to make it clear for everyone. Okay, any question up to this point? Or you don't know what to ask? You guys get lost.
We'll be looking at the video over and over and over and over.
Exactly. You have to do it. Then up to the certain point, you understand everything.
Right.
The thing is we keep doing over and over, they go to your brain. You never know. However, up to the point, you see everything easy, everything you know. They already in your brain. Okay. Now, the next common collector. Common collector, they get another name for this amplifier, emitter follower. So make sure you have to understand. They can say common collector amplifier or emitter amplifier follower. Same name. Okay. Otherwise, you know the common collector, but they're asking you about the emitter follower. You don't know which one. That's just a one name. The collector is FAC route. That's what I already telling you. Common collector will be AC route. Common emitter will be AC route. Common base will be AC route. Okay? Stable voltage gain. Now, this what the thing you have to memorize. Input impedance is high. Output low distortion. That means they get low noise. Okay?
Is the output impedance low?
They're not telling you in here. We'll go through that calculation. Okay?
All right.
Then we'll be safe. Okay, so that will be also okay. Okay. That's what I just given to you. Okay, that common emitter. So that's supposed to be before CC. Okay, they're supposed to be in here. I will be correct that. Now,
Oh, that one there is supposed to be before
right, before
Okay.
common collector.
Okay.
Now, this is a common collector circuit. Okay, this is the input here. Okay, this is input applied to the base. Output will be coming out from emitter. Okay,
Right.
no bypass capacitor. You get C1 DC blocking AC coupling. Same thing for C2. Okay, so when you're looking into the circuitry, if you see input applied to the base, output from the emitter, you must understand this is a common collector. Okay, they already given to you here. Input applied to the base, output from emitter. C1 and C2, they be blocking RAC coupling. Input, output will be in phase. You see that input go up, output go up, input going down, output going down. That's the total thing you must be know. If you not want to go detailed calculation, I don't care. But that's the minimum thing technicians have to know. You see the circuitry, you can say this is a common emitter or emitter follower. Input applied to the base, output from the emitter. Okay, input, output will be in phase, Okay. Now, this AC model, this will be more easier. Okay, so basically this is the base. This is the collector will be rounded. Okay, that's what common collector. And output from meter. This will be meter right here. Okay, and this will be go into output, and you get the load RL. Okay, and that will be RE. Basically, this has to be R big E. Okay, the thing you know by heart. Now, see, if they want to do calculation, first thing R in base. R in base, that means this is looking from the base to the round. Okay, R in base, they given you the formula beta times R prime E. Okay, plus R big E. So you get this one, adding this one to time the beta. Okay, that you can get R in base. Okay, and now if you're looking into the formula here, R in base beta times R big E, that means they say R prime E is too small. Then you want to calculate the total input impedance. You're looking from here, from generator to the amplifier. You can see you get a R1 parallel R2 and also parallel with R in base. That's what we just do calculation here. Okay. And if you want to calculate the output resistance, that means you're looking from here into the amplifier. In here they say output resistance R small e, but normally we want to using the output impedance. That means you're looking into the output, okay? Then how much resistance you can get. If you're looking in that one, you can get right here. RL, load resistance, and here RE. So basically, RE and RL in parallel. So that's why right here. Output resistance, R big E parallel RL. Then finally, they calculate the voltage gain. Voltage gain will be equal R big E divided to R prime E plus R big E. Okay, and finally V out equal AV times V in. Okay, and this is what they do in calculation here. Let's see. Okay, however, I need to add in a little more detail on this circuitry here. Okay, from next update, I will be adding more, and I will be trying to go in calculation formula for you. Okay, any question? up to this point. You see, even myself, every time I go through the same thing we did in the past, but I can find some still missing to me, okay? And try to make it more clear for everyone. Okay, any question up to this point? No? You get any question, anything? If it's not, hello Sam,
Hello, Mr. Pham.
you ready for the quiz number 3?
Yes, sir.
Okay, I will be stop my iPad. Okay,
Okay.
that it you take over for me.
Okay, so make sure you download the quiz number 3. Okay, I did put the link on the chat, so click on that and so download that the answer sheet. Okay, let me
I
go
can also
ahead.
take pictures from with my phone, right?
Do whatever you need to.
I'm about to take pictures of the questions with my phone.
Do whatever you need to.
Thank you.
Okay, so let me go share screen. Okay, share. All right. Let me see in slideshow. Okay, here we go. Okay, can you all see that?
Yes.
Okay, very good. Okay, so that's pretty much it. So make sure you upload it to the website and it's due before 12 noon tomorrow. Okay. Let me check out the chat. Stop sharing first. Okay, chat.
Good night, Mr. Sammy.
Good night. Bye-bye.
Good night. Thank you.
Okay, so Sabrina, you look at number 13. Let me see on that. Okay. Let me see, share. Okay. Okay, so we're gonna be. Sure. We're on number 13. Oops, let me stop. Share the number 13. Oops. Number 13. Still way behind. Okay. Do you see that, Sabrina? Okay. All right, so let me see, share. Let me see, that was the number 13. Oops, I closed it. 13, let me see, quiz 3, number 13. Current.
Good night.
Good night. Okay, can you see that, Sabrina?
Good night.
Good night.
Good night.
Okay, so that's it. So make sure everyone upload it to the website and it's due before 12 noon tomorrow. Okay.
Okay.
Okay, back to you, Mr. Pham.
Everybody
you.
go straight home.
Thank you, Sam.
Thank you.